Hello friends and welcome back to our today's tutorial. In this tutorial, we're going to look at how to divide surds or radical expressions. When we talk about radical expression or surds, we talk about that aspect of algebra that involves this kind of sign. So each time you see this sign, this is a radical sign. It talks about radical expression or surd expression, okay? And for surd in particular, we talk about non-perfect squares, non-perfect cubes, and the rest of them. So let's see how to divide this. If you are to divide surds, indirectly, the question wants you to rationalize it. Okay, so each time you are dividing a surd, you are simply asked to rationalize. And what do you mean by to rationalize? To rationalize simply means to remove the radical sign. And this radical sign, as in this context, the radical sign we want to remove is the one at the denominator. So in rationalizing this kind of question, our target is on removing the radical sign at the denominator. And when you do that, it means you have rationalized it, because surds are irrational numbers. Okay, so how do you rationalize this? Looking at the denominator, you notice you have two surds that are joined by an operation, this addition sign. So when you have this kind of expression, we call it expression, okay? What it simply means is that you need to get its conjugate. Now, what is that conjugate? The conjugate simply means the change of sign. To change sign means to conjugate, okay? So the conjugate of this will now be 3 root 5 minus root 2. So what do we do with this conjugate? We are going to use this conjugate to multiply the numerator of this question and also the denominator. So let's do that together. So to answer this, we are going to have solution. This will give us 5 minus 2 root 10 all over 3 root 5 plus root 2. Now, please be careful. You're not supposed to do 5 minus 2. Students will do just 5 minus 2 to give them 3 root 10 over 3 root 5 plus this. Please, this is wrong. Why? You cannot subtract these two because they are not the same terms. You don't subtract unlike terms. This one is just 5 as a number, a constant. And this one is a radical sign. So they are not the same. Okay, so you don't subtract it. Now let me show you what you would do. So what you are now going to do, like we said, is to use this conjugate to multiply the numerator and the denominator. So we're going to do it to have 3 root 5 minus root 2 all over. Still repeat this, 3 root 5 minus root 2. Did you see it now? Now let's multiply out. To multiply out, this will multiply the whole of this. So we have 5 minus 2 root 10. We'll be multiplying 3 root 5 minus root 2 all over. You multiply this also to have 3 root 5 plus root 2 all over 3 root 5 minus root 2. So what do you do now? Apply your simple algebra skills. You are going to expand this, okay? So let's expand this now. To do that, we are going to have 5. Watch what we have there. 5 minus 2 root 10 and 3 root 5 minus root 2. Let's expand it. In expanding this, you use this to multiply this and also use it to multiply this. So watch. 5 we multiply 3 root 5. Remember, the number we multiply number, surd we multiply surd, okay? So 5 multiplies 3 root 5. When you multiply 5 by 3 root 5, it gives you 5 will multiply 3 to give you 15. You return this. Okay, so if you multiply this, it will give us, so let's write it out. If you multiply this, it will give us 15 root 5. Now use this 5 to multiply surd 2. It will give you, when you multiply 5 by root 2, it will just give you 5 root 2. Okay, so we're going to have, remember it has negative, so we have negative 5 root 2. Okay, now use this also to multiply this. If you multiply it, you are going to have negative 2 root 10 multiplying 3 root 5. Negative 2 multiplies this, negative 6. Then the root will multiply root. If it does that, 10 will multiply 5 to give us 50. Is that okay? So we're going to have negative 6 root 50. Then do same for this. Use this to multiply this. negative 2 root 10 multiplies negative root 2. Negative multiplies negative is positive. Then 2 will multiply, remember there's a coefficient 1, so it will be 2. 10 multiplies this will give us 20. So we're going to have, let's bring it down. So we're going to have 2 root 20. Then this will be over. When you look at that denominator, what do you observe? At the denominator, you observe that what you have here is the same with what is here. If you watch, the only difference is in the sign. So what do? What you need to do now is, because they are the same, the difference in the sign, remember your difference of two squares, which says that a squared minus b squared is a plus b and a minus b. So what it means is that, look at this, 3 root 5 plus root 2 and 3 root 5 minus root 2. So you see that it's just the same with this. In that case, this will give us 3 root 5 raised to power 2 minus root 2 raised to power 2. So it means that this can be written like this. So we're going to now have 3 root 5 raised to power 2 minus root 2 raised to power 2. I hope it's clear. So let's simplify now. So we're going to now have, this will give us 15 root 5 minus 5 root 2. Then when you have negative 6 root 50, this is having a perfect square. Remember, we are simplifying. So we're going to remove the perfect square. Until you do that, it means you have not yet simplified it. So let's remove it. The highest perfect square in this, perfect square are those square roots that give a whole number. Okay, so the highest one in this is 25. So that when you multiply 25 by 2, it gives you 50. So what it means is that we can write this like this, 25 multiply 2, to give us back this. So we're going to have plus 2. This root 20 also has a perfect square, which is 4. And when you multiply 4 by 5, it gives you back 20. Is that okay? So this will now be over. This square, when you have 3 root 5 raised to power 2, it is the same as 3 root 5 multiply 3 root 5. It will be 2. So 3 multiplies 3 will give us 9. And when you have root 5 multiplying root 5, it gives you root 5 raised to power 2. The square will cancel the square root, so you are going to have 5 left. So you see what we have. Bring down your minus sign. When you have this will cancel this, we are going to have 2. You see, it's becoming interesting. So what do you do next now? You simplify further. We have 5 root 5 minus 5 root 2. Square root of 25 is 5. And if you bring it out, use it to multiply 6. To give you negative 30. This is not perfect, so leave it in the roots. Plus the square root of 4 is 2. Bring it out, use it to multiply 2. It will give us 4. So we have 4 root 5. And this is over. 9 multiplies this is 45 minus 2. You see, it's simple now. So what do you do now? You notice there are terms here that are the same. This is the same with this, so you can add their coefficients. We call this coefficient because they are multiplying the radicands. So 15 plus 4 will give us 19, so we have 19 root 5. This is the same with this in the roots, so you can add their coefficients. And negative 5, negative 30 will give us negative 35 root 2 all over. If you subtract this, you have 43. So you see, you can leave your answer like this. Okay, so this is what we have. If you still want to simplify further, this is what we are going to have. You are going to have, you can leave it as all, 19 over 43 root 5 minus 35 over 43 root 2. Either this or this is acceptable. And I hope this helps you a lot. If it did, don't forget to share this tutorial. Remember, you can tell us how much it's helpful in the comment section. I will see you in our next class, and bye-bye.